All right, moving into 6.2, and here we're going to introduce what a polynomial is and how to perform some operations on polynomials. And then in a second video, I'm going to talk about what's known as the binomial theorem. Okay, so a polynomial is defined to be a monomial or a sum of monomials. Okay, so that tells me that all of the monomials that we studied in our first section, those can all be considered polynomials. Polynomial is just kind of a generalized term, okay? And then if you add or subtract any monomials together, those can be considered a polynomial as well. So from there, we have special names for different polynomials based on how many terms they have. So a monomial would be, again, a polynomial that just has one term. So that would be something like negative 2x, okay? A binomial would be a polynomial with two unlike terms. So just think of me taking the first monomial of negative 2x and then adding another term to it. And then a trinomial would be a polynomial with three unlike terms. Let's say I take the binomial of negative 2x plus 3 and I add to it x squared. Now I have a trinomial, okay? Now, the degree of a polynomial is going to be a little bit different to find than how we found the degree of a monomial, okay? The degree for a polynomial is just defined to be the largest degree of all of its monomials. So you don't add all the exponents up from term to term. Instead, you just look at each term's degree separately, okay? So this first monomial has four terms. The first term has a degree of 3, the next has a degree of 2, then a degree of 1, and then a degree of 0. So based on this definition, I'm going to choose the largest value there, which makes the degree of this polynomial a 3. Okay. The next polynomial has four terms. The first term has a degree of 3. The next has a degree of 4. Next is a degree of 3, and then a degree of 2. Obviously, 4 is the largest number, so we'll say this has a degree of 4. Okay. All right, now let's perform some different operations on our polynomials. Okay, so starting with addition and subtraction, it's really simple. Just combine like terms. Okay, so for the first example A here, you have a trinomial being added with another trinomial. All right, and again, add the like terms, which are terms that have the same variable raised to the same power. So these are like terms. They're going to add to 2x squared. Then these are like terms. They're going to add to negative 14x. And then the constants are like terms. They're going to add to negative 3. There's your resulting trinomial. All right, now for the example in B here, you got to be careful with the subtraction, okay? Make sure that this subtraction applies to all three terms of the second trinomial there, okay? So if I'm doing 2a cubed subtracted by a cubed, then that's going to give me just a cubed. 5a subtracted by negative 3a would actually give me positive 8a. And then negative 7 subtracted by 2 is going to give me 9. So just be careful on the subtractions, all right? And then one final example here, two trinomials being added together, their terms are kind of mixed up. 9x squared is a like term with negative 2x squared. Those will add to give us negative 3x squared. 3xy is a like term with 7xy. Those will add to give us 10xy. And then negative 4 is, of course, a like term with 3. Those will add to give us negative 1. Okay. All right, to multiply polynomials together, you're simply going to use the distributive property. All right, so in A here, I have a monomial of negative y that's multiplying a trinomial. You simply need to distribute negative y to all 3 terms of the trinomial, and here's where you would use your product property of exponents. Okay, negative y times 4y squared would be negative 4y to the third. Negative y times 2y would be negative 2y squared. And negative y times negative 3 would be positive 3y. Okay. Part B, this should be nothing new to you. It's just a binomial times a binomial. You're going to use the distributive property here as well. We're going to take 3p, multiply it by 5p to give us 15p squared. Then 3p to 1, that'll give us 3p. Then we'll also distribute 2 to 5p, that'll give us 10p. And then 2 to 1, that'll give us 2. And then we want to notice we've got a couple like terms there that can be combined. Give us 13p in the middle. All right. Third example, we've got a trinomial times a binomial. Once again, just distribute each term of the trinomial to each term of the binomial. So starting with a squared times a, that's going to give you a cubed. A squared times 2 will give you 2a squared. Then I'll do 3a times a, that's 3a squared. 3a times 2 is 6a. Then I'll also do negative 4 times a, negative 4 times 2. Notice I've got 2 quadratic-like terms and 2 linear-like terms. So this will lead me to a cubed plus 5a squared plus 2a minus 8. Okay. All right, now I want to transition to squaring a binomial. And this to me should be the main focus of this whole video lesson, okay? I want to make sure that we really are good with what I'm about to show you, all right? So we know that squaring something just means multiply it by itself, right? All right, so if I have the binomial of a plus 2 raised to the second power, that's the same as saying a plus b multiplied by a plus b, okay? And when I see it written like that, I know to use the distributive property, and that's going to give me a times a, which is a squared, a times b, which is ab, b times a, which is also ab, and b times b, which is b squared. And then I have a couple like terms here. I have 2 ab's, so this becomes a squared plus 2ab plus b squared. Okay. Now, I want you to think of this result as, think of it like a formula that can be used for squaring a binomial. Okay. So we have to know that when we square a binomial, it's actually going to result in a trinomial. And to get the first term of the trinomial, you're going to simply square a. To get the second term of the trinomial, you're going to multiply a and b together, and then you're going to have to double it. And the reason I'm doubling it is because of the fact that that product of AB happens twice in the distributive property. Okay, and then to get your third term, you simply square your b value. All right. So if you get used to this formula, it can make the squaring process a lot quicker. All right. And I want to stress this because squaring a binomial is just going to be a regular occurrence as we move forward throughout the rest of this chapter and beyond into the rest of this course and future courses, okay? So rather than having to like multiply it all out and use that distributive property every time, use this, get used to using this formula, okay? So that's what we're going to do here on this last set of examples, okay? Let me write the pattern down, or the formula. So we said that a plus b raised to the second is like a squared plus 2ab plus b squared. All right, so here in example A, I have x minus 4 being raised to the second power. So think of your a value as x, and think of your b value as -4 here. All right. If I apply the formula from above, then this is going to equal x to the second plus 2 times my a value, which is x, times my b value, which is -4, plus my b value squared. So that's going to give me x squared minus 8x plus 16. Okay. Let's try to shortcut it on the second example here. So if I want to take 2x minus 1 to the second power, I'm going to square the first term of 2x. That's going to give me 4x squared. Then I'm going to multiply 2x with -1 and double that result. So 2x times -1 is -2x. Doubling that gives me -4x. And then squared -1, that gives me +1. All right, so notice I got to the trinomial result very quickly by using that formula, that pattern from above.